In this video, you'll learn about polymorphism. The word polymorphism comes from two root words, poly, which means many, and morph, which means shape. So polymorphism is the ability to have many shapes or many forms. So polymorphism applies to objects of classes, and those classes are subclasses of other classes. So when we have an object that passes the ISA test, meaning we can say that object is the subclass and that object is a superclass, then we say that that object is polymorphic. So here we have our example with person, class, and then student and teacher are each subclasses of the person class. So we can create a polymorphic object that is a teacher and a person. So our person object T is initialized using the teacher constructor, but it's declared as a person. So we can declare an object as any class that it passes the ISA test for. So since T is initialized as a teacher and a teacher is a person, then we could put either teacher or person here, and this line of code will compile. So T is polymorphic because it passes the ISA test for teacher and it passes the ISA test for person. So then we can print out T. It will call our toString for this object. And then we can try to create a student object. So the student constructor requires an array of teacher objects. So when we create our person, back here, we're creating an array of teacher objects, and we're passing this array to our student constructor right here. Now you'll notice that we actually get a compiler error over here saying that we have incompatible types. Person cannot be converted to teacher, and it's pointing at our person object T. So because we declared T as a person object, then when our compiler, which is the program that checks for errors and then converts our code to our object code. So when our compiler checks through this, it goes, okay, T is a person, but we're making an array of teachers, so all of the elements in here have to be teachers. It only looks at what we're declaring our objects as, not what we are initializing them as. So in order to fix this and still allow our teacher, Ms. Doe, to be put into this teacher array, we're going to have to use casting. So way back at the beginning of the course, we learned about casting for converting ints to doubles and doubles to ints. We can also use casting with objects as long as we are casting our object to another type that it passes the ISA test for. So since teacher does pass the ISA test for the teacher class, then we can cast our T object to be a teacher. So same syntax here as we're used to with casting. We put in parentheses the type that we want to cast to. So we're saying even though we declared T as a person object, we're casting it to a teacher. And we can do that because we did initialize T as a teacher object. If you tried to do this for a regular person object that you just called the person constructor for, then you'd run into other problems. But this will fix this error. So now we no longer have that error. So we'll get to this other error in a minute. So this is how we cast between different object types. So once we've done that, then we can call our student constructor. We have this valid teacher array now to pass to the constructor, and we can print out our student ID. So student S, notice we declared and initialized as type student. So that's kind of the way that we're used to doing things. But because student is a person, we could also create a student object where we declare it as a person and initialize it as a student. So this is very similar to what we did with our teacher object up here. So S2 is polymorphic. It passes the is a test for student. It passes the is a test for person. So then we can go ahead and print out S2 that calls our toString method automatically whenever we print an object. And then we can try to print the student ID just like we did up here. But we're getting this error. We cannot find the symbol and it's pointing at the dot right before get student ID. So it doesn't know what get student ID is for our student S2. That is because we declared S2 as a person. So again, the compiler doesn't care what you initialize it as. It only declares what you declare it as. So if we want to call get student ID for S2, then we have to use casting again. So we're going to cast S2 to a student. And then because of our order of operations with the dot operator and casting, we actually have to put a set of parentheses around this casting to force it to cast S2 to a student before it runs the get student ID. So now this should fix that error and it will recognize that S2 is a student object. All right, so now our compiler has checked through everything, verified that all of our method calls are valid, and so then we're able to run. That's what we see with our second command here. So the first command, javac, is our compiling. Our second command with Java is when it actually runs the code and executes it. So let's go back through and just confirm that all of this is correct. So we start by printing out our person T, which is initialized as a teacher. So when we print that, it calls the toString, and it actually calls toString from the teacher class. Even though we declared this as a person, it runs the teacher version. So if we look in here, we see that we didn't actually override our toString. So we're just inheriting from person, but it will check teacher first to see if there was a toString. And since there's not, it's just going to come into the superclass, the person class, and run this version where it prints the name and birthday. And that's what we see here. Next up, we have our student ID. So we're just calling s.getStudentID. That prints this number. And then we are printing some things for S2. So when we print S2, which is declared as a person but initialized as a student, it has to make sure that at compile time, when the compiler is checking this, it looks in the person class to make sure there is a toString method. However, when it's running it, so at runtime, it first looks in the student class for the toString method. And in student, we do have an override of toString. So it does the superclass version, and then it adds on the student ID. And you can see that right here. So again, the compiler just checks the declared type to make sure that that class has the method you're calling, but at runtime it actually runs the version in the initialized class. All right, and then we can also print out the ID, so we see that here. Now this last line, we are calling the hasSameName method on S2. So the only way this compiles is if the person class has a method called hasSameName, and it does, so that's why we didn't get an error. And it has a parameter that is a person. So whenever we call this, we have to pass in a person object. And then it just compares the name of the object that you called it on to the name of the parameter. So again, this parameter is declared as a person object. But if you look back here in main, we are passing it S. S was declared as a student. But it's okay, we can still pass it to this method because S is also a person. S is polymorphic. Any object of our subclass is polymorphic because it passes ISA for both the subclass and the superclass. So things to remember when you're working with polymorphism: the compiler checks what type you declare it as, but when you're actually running it, Java will run the version of the method that goes with the initialized type. Also, all objects of subclasses are polymorphic, so they pass the ISA test for more than one class. And so if you have a parameter that requires a type of the superclass, you can pass it either an object that's declared as that superclass or an object of any of the subclasses of that class.